In this video, I'm going to be talking about circles, specifically how to find the equation of a circle and how to find where a straight line intersects a circle. Before we get into it, why should we spend time studying circles? Well, many things in the world around us are circular or almost circular, such as the orbits of the planets or the circumference of the Earth or the human eye. Also, we often want to create circular things, and in order to create, we need to understand. So let's start with some things that you already know. Firstly, the midpoint formula is going to be useful here. The midpoint formula looks like this, and it allows you to find the midpoint of a line segment given the two coordinates of the two endpoints. Another thing we'll be using is the perpendicular bisector. A perpendicular bisector is perpendicular to a line segment such as AB. That means it's at right angles and cuts AB in half. So something like this picture here, you can see we have that line segment AB, and this line is the perpendicular bisector. It's at 90 degrees to AB and it cuts AB in half. Something else you need to remember is that the gradients of perpendicular lines are negative reciprocals, meaning their product is -1. So for example, if AB had a gradient of 2, its perpendicular bisector will have a gradient of -1/2. Let's quickly revise these 2 points. So if you're looking for the midpoint of a line, let's say we had this line and the two endpoints are 1, 3 and 9, 5, and we want to find the midpoint of that line. We can use the midpoint formula. So add the x coordinates together and divide by 2. So this x coordinate is 1, the other x coordinate is 9. So 1 plus 9 divided by 2 will give us the x coordinate of the midpoint, and 3 plus 5 divided by 2 will give us the y coordinate of the midpoint. So 1 plus 9 divided by 2 is 5. And 3 plus 5 divided by 2 is 4, so we get a midpoint of 5, 4. Let's look at finding the gradient of a perpendicular line. So if we're given a line with an equation y equals -4x plus 3, you will often need to find the gradient of the line perpendicular to that line. So what is the gradient of this perpendicular line? Well, you should be able to pretty quickly tell me what it is, because it is the negative reciprocal of the gradient of this line. Remember, the gradient is the coefficient of x, so we know the gradient of our original line is -4, and the negative reciprocal of that is 1/4, positive 1/4. So the gradient of this perpendicular line is 1/4. Let me go into a bit more detail on that. So to find the gradient of the perpendicular line, you can flip -4/1 and change the sign. So if you find this useful, you can write this gradient of -4 as a fraction. So that would be -4/1. And then you can see that if you flip that around, it's going to be 1/4. And we also need to change the sign to a positive. So -4/1 becomes positive 1/4. And you can see if you multiply those together, you get -1. So positive 1/4 is the gradient of the line perpendicular to y equals -4x plus 3. Now, if you wanted to find the equation of this line, you'd need more information. You need a point on that line, such as where they intersect. But for now, all we could do with that example is find the gradient. Okay, hopefully that's pretty straightforward. Let's move on to the equation of a circle. Most commonly, we write the equation of a circle like this. X take a all squared plus y take b all squared equals r squared, where the center is AB and the radius is r. So if you're given an equation in this form and you have some numbers here, you can straight away say what the center is. And if you have a number over here, you take the square root to get the radius. I would call this the standard equation of a circle. You can also have what's called the expanded form of the equation of a circle, and it looks like this: x squared plus y squared plus 2fx plus 2gy plus c equals 0. You can get this equation by expanding out these brackets, and from this equation, the center is -f -g, and the radius is the square root of f squared plus g squared take c. And I'll look at an example involving the expanded form in a minute. But first, I just want to demonstrate where this equation comes from, why it looks like this. So let's look at an example. This question says, write down the equation of the circle with center 5, 7 and radius 4. So let's draw a diagram with center at 5, 7, and let's pick a point on that circle. It could be anywhere, and I'm just going to put it up here, and I'm going to call that xy. So that's representing any point on this circle. They've also told us the radius has a length of 4, and now we want to find a relationship between these two variables. How could we do that? Well, let's draw a right angled triangle in here. horizontal line from the center and up to that point we picked. And now let's look at the legs of this right angle triangle. What is the length of this leg here? Well, it's the difference between the x coordinates. So it would be this x coordinate, which we've just labeled x, take 5, the x coordinate of the center. So that leg of that right angle triangle has a length of x, take 5. The vertical leg will be the difference between the y coordinates, so y takes 7. And now, how can we relate these three things? What's the theorem that we usually use to find the hypotenuse of a right angle triangle? It's Pythagoras' theorem, right? So using Pythagoras' theorem, we can square the legs and add them together, and that will be equal to the hypotenuse squared. So we get x take 5 all squared plus y take 7 all squared equal to 4 squared. And then we can write 4 squared as 16, so we get x take 5 all squared plus y take 7 all squared equal to 16. And that's our equation of this circle. It's a relationship between the x and y coordinates. Now you might ask the question, what if I put this point over here somewhere? Wouldn't this length then be 5 take x? And wouldn't this length then be 7 take y? Yes, they would. You're absolutely correct. And you could in fact write this equation of this circle as 5 take x squared plus 7 take y squared equal to 16. These are the same equation. Because you're squaring these differences, you will always get the same answer. X take 5 is the same as 5 take x after you square them. Okay, so you could write it in this way. It's not usually written this way. I don't know why. I guess it looks neater this way with the x and the y terms, at the front of the brackets. But if you want to be different, if you want to be a mathematical maverick, you can start writing your circle equations this way if you like. Okay. So this is the same equation, but it's not usually written this way. All right, let's look at another example. This question says, write down the equation of the circle with center 1, 0 and radius 9. So use what we've just talked about. Write down the equation of that circle. I would suggest always starting these questions by writing down that equation. It helps you to memorize it, and it's easy to see then where you should plug in these numbers. So remember, the center is A, B. So all we need to do here is plug 1 in for A and 0 in for B and 9 in for R. So plug those numbers in, we get x take 1 all squared plus y take 0 all squared equal to 9 squared. Now we're not going to leave that 0 there. There's no point writing y take 0. That would just be y. So we can just write y squared, and we also want to square 9. So we get x take 1 all squared plus y squared equal to 81. And that's our final answer for that question. Let's look at another one. This question says a circle has equation x plus 3 all squared plus y take 4 all squared equal to 18. Write down the center and the radius of the circle. Well, this is the reverse of the previous question. Here we need to look at these numbers, plus 3 and negative 4. And notice in the general equation, it's always a negative a and negative b. And that gives us the positive numbers for the center. So you need to reverse these signs to find the center. So if it says x plus 3 all squared, that means the x coordinate of the center will be negative 3, and the y coordinate of the center will be positive 4. And then we need to take the square root of 18 to get the radius. So our center is negative 3, 4, and our radius is the square root of 18, which we can write as the square root of 9 times 2, which is 3 root 2. Remember your surds laws to simplify that surd there. Okay, so now let's look at an example where the equation is written in expanded form. So this question says, find the center and the radius of the circle with the equation x squared plus y squared take 14x plus 16y take 12 equal to 0. I'm going to show you two ways you can do this. The first method does not involve completing the square. Personally, I would not recommend using this method, but if you absolutely hate completing the square for some reason, maybe you would prefer this method. So I'll show it to you anyway. So let's write down the expanded form of the equation of a circle. That was x squared plus y squared plus 2fx plus 2gy plus c equal to 0. And remember, when the equation is written in this form, the center is negative f negative g, and the radius is the square root of f squared plus g squared take c. Okay, so firstly we need to write this equation in this form. So we need 2 times something x plus 2 times something y, and then with the c on the end. Well, we've already got the c, it's negative 12. So we just need to divide these numbers by 2. So let me show you what I mean. We've got x squared plus y squared, they stay the same. Then divide this negative 14 by 2, and I'm left with negative 7x. So hopefully you can see what I've done there. I've just basically factorized out of 2 so that we have 2fx, where f is negative 7. Same for 16y, I've factorized out of 2, so now I have 8y in the brackets, and then I've still got that negative 12 on the end. So now we want to focus on these three numbers. The center is going to be negative f, so negative 7, in other words, positive 7, and the y coordinate will be negative g, so negative 8. So it will be 7, negative 8 for our center. And then we need to use those numbers to find the radius. So let's see what that looks like. We get a center of 7, negative 8, and our radius is the square root of f squared. Now, because we're squaring it, we don't need to include the negative. You can write negative 7 squared if you like. I just generally ignore the negative and just write 7 squared plus 8 squared plus 12, because it was subtract negative 12, so it's going to be plus 12. 7 squared plus 8 squared plus 12 is 125, so we get the square root of 125, which simplifies to 5 root 5. So our answer there is 7, negative 8, and 5 root 5. The other method I want to show you quickly, this is basically completing the square method. What you want to do is to write this equation in the way that we typically see the equation of a circle. So we have the bracket squared, x plus something squared plus y plus something squared equals whatever. And this involves completing the square. So how do we complete the square? We take half of the coefficient of x. That goes inside the brackets. So x takes 7 all squared, and then we need to subtract that square. So x takes 7 all squared, subtract 7 squared, which is 49. And then for 16y, we take half of 16, so it's y plus 8 all squared, and then subtract 8 squared, so subtract 64, and we have that subtract 12 on the end as well. Then remember what the general equation looks like. We have all of the constants on the right and these two brackets on the left. So let's do that then. We have x takes 7 all squared plus y plus 8 all squared equal to 49 plus 64 plus 12. I've added those three constants to the right hand side. Then we get x takes 7 all squared plus y plus 8 all squared equal to 125. And from this equation, we can read off the center and the radius. So the center will be 7, negative 8, and the radius will be the square root of 125, which is 5 root 5. So really with those two methods, you're doing the same operations, you're just doing them in a different order, and take your pick as to which one you prefer. Okay, another thing that is useful when studying circles is the distance formula. This is another thing that you already know, but let's review it again. So the distance formula says the distance between two coordinates is the square root of x2, take x1, so the difference between the two x coordinates squared plus the difference between the two y coordinates squared. This is basically what we just used to find the equation of the circle, but I thought I'd give another example because you're going to be using this quite a bit. So if we have a line between 2 points, and let's call those points x1, y1 and x2, y2, how can we find the length of that line? Well, let's draw our right angle triangle, and the distance of the horizontal leg will be x2 take x1, and the vertical leg will be the difference between the y coordinates, y2 take y1. So how do we find the hypotenuse? We take the square of both legs and add them together, so we get the hypotenuse squared is equal to x2 take x1 squared plus y2 take y1 squared. That's the Pythagoras' theorem again. And then d by itself would be the square root of this. So that's where the distance formula comes from. And now let's introduce some numbers. So let's say this point was 1, 3, and this point was 13, 8. What would be the length of that line? Well, let's calculate these lengths now. So x2 take x1 would be 13 take 1. So that's 12. y2 take y1, 8 take 3. Is 5. So looking at this formula, we would have 12 squared plus 5 squared. So the square root of 12 squared plus 5 squared, that's the square root of 169, that's 13. So that's how you can use the distance formula to find the length between any 2 points. All right, now let's look at another example. This is more of an exam style question. This question says the points D, E, and F lie in the circle C as shown in the diagram. So you can see here we have the points D, E, and F, and we have coordinates for D and F. And it says, given that angle DEF is 90 degrees, find an equation for C. Now, if I was not sure where to start on this question, I would be wondering why they tell me angle DEF is 90 degrees. Does that ring any bells? Think back to your circle theorems. Can you think of a circle theorem that we can use here to help us solve this? Have you got it? Yes, well done. The circle theorem we're going to use here is the angle in a semicircle theorem. That circle theorem says that when you have a diameter of a circle and you draw two lines connected to the circumference, in other words, you draw a triangle with one leg that's the diameter, the angle in the semicircle must be 90 degrees. And we can reverse that to say, whenever you have a 90-degree triangle or a right triangle inside a circle, then the longest side must be the diameter of the circle. That's the only time you can have a right triangle inside a circle. So that's what that bit of information is telling us. So we can state, because angle DEF equals 90 degrees, this tells us that DF is the diameter of the circle. So from D to F must be the diameter. Why is this useful? Well, if I know this is the diameter, and I have these 2 points, D and F, I can find the midpoint, that will be the center of the circle, and then I can find the radius. So firstly, let's find the midpoint of that line using the midpoint formula. So the center is x1 plus x2 on 2, y1 plus y2 on 2. So negative 12 plus 2 divided by 2, and negative 3 plus negative 5 divided by 2. Negative 12 plus 2 is negative 10 divided by 2 is negative 5. Negative 3 plus negative 5 is negative 8 divided by 2 is negative 4. So now we have the center of the circle. Let's go ahead and write that in. Okay, now we can find the radius using the distance formula. So we could pick either of these points, D or F. I'm going to pick F because the numbers are smaller and I think it would be simpler to calculate. So the radius is going to be the distance between these 2 points. Using the distance formula we just talked about, this will be x2 take x1 squared plus y2 take y1 squared. Plugging these numbers in, you can do it in either order. You can do 2 take negative 5 or negative 5 take 2. I'm going to do it that way. So 2 subtract negative 5 squared plus negative 5 take negative 4 all squared. 2 take negative 5 is 2 plus 5, so that's 7. Negative 5 take negative 4 is negative 5 plus 4, that's negative 1. But I've just ignored the negative because of squaring it, so it's 7 squared plus 1 squared, which is the square root of 50. So that's the radius. Now we could simplify that third, but we're not going to bother because we're about to write the equation of the circle, and that means we're going to square this. So don't bother simplifying that third if it asks you to find the equation, because then we write it like this. So the equation of the circle using that center of negative 5, negative 4 is x plus 5. Remember, when we plug those numbers in, we change the sign. So it's x plus 5 squared plus y plus 4 all squared equal to the radius squared, which is 50. And that's our final answer for that question. Now let's talk about intersecting straight lines and circles. So a straight line can intersect a circle at 0, 1, or 2 points. So it might not intersect the circle at all. It might be a tangent and just touch the circle at 1 point, or it might be a chord and intersect the circle at 2 points. Finding these intersection points involves solving simultaneous equations. And this is something you already know how to do from GCSE mathematics. So for example, you might be asked, when does the line y equals mx plus c meet the circle so and so? So they're the type of questions you're going to get here. And this involves substituting mx plus c into the circle's equation for y. Often these questions are made more difficult by introducing unknown constants. For example, given a line y equals kx, you need to find the range of values for k or something similar. And I will go through an example in a minute to show you what I mean by that. Okay, something you need to remember before we continue is when solving quadratics, there can either be 0, 1, or 2 solutions. And you need to know how this relates to the discriminant. Now, if you're not sure what I mean when I say the discriminant, I highly encourage you to revise section 2.5, which is on the discriminant if you are unsure here. And I'll leave a link to a video where I went through this in the description. So check out the description if you want to go back and do some revision on the discriminant before we continue. So now let's look at some examples involving straight lines and circles. This question says, find the coordinates of the point where the line y equals x plus 5 meets the circle x squared plus y take 2 all squared equals 29. Think back to your knowledge of solving simultaneous equations, and I have a video on this if you want to do some extra revision. The key point is to realize that when the line intersects with the circle, the y and the x coordinates will be the same. So what that means is we can take this value for y on the straight line, so x plus 5, and substitute it into the equation of the circle for y here. This is because the y values will be the same at the points where they intersect. So that's how we start off these types of questions. So we're going to start with x squared plus x plus y take 2 all squared equal to 29. I hope you can see where that x plus 5 has come from. Then simplify this equation. So we've got x plus 5 take 2. That's going to be x plus 3 all squared. Expand out those brackets. So we get x squared plus 6x plus 9 equal to 29. Continue simplifying. We're going to have 2 lots of x squared plus 6x, subtract 20. So I've subtracted 29 from the left hand side. This is all equal to 0. And then can you see any common factors? Divide by 2. We get x squared plus 3x take 10 equal to 0. And this is a quadratic that we can factorize. So see if you can factorize that yourself. Factors of 10 that make 3 are 5 and 2. So we get x plus 5 multiplied by x take 2 equal to 0. This means that x equals negative 5 or x equals 2. Then plug these values into the straight line equation to get the y values of the intersection points. So negative 5 plus 5 is 0 and 2 plus 5 is 7. So we get the coordinates of negative 5, 0 and 2, 7. That's your final answer there. And we could draw a quick diagram just to show you what this would look like. You wouldn't have to do this to answer the question, but just to give a visual. So this circle had a center of 0, 2, and the straight line might look something like this. This is just a rough sketch. And what we just found was the coordinates of these 2 points where the straight line intersects with the circle. So the first one was negative 5, 0. The other one was 2, 7. Now let's look at one of those questions that I mentioned where you have y equal to kx. So this question says the line with equation y equals kx intersects the circle with equation x squared take 10x plus y squared take 12y plus 57 equals 0 at 2 distinct points. And the question is, determine the range of possible values for k round to 2 decimal places. This is an exam style question which is worth 8 marks. So it is a difficult question, but it's worth revising because there are potentially a lot of marks involved with these types of questions. And I would encourage you to give this a go using the same method we just used and see how far you get. You might be surprised. You might actually be able to work yourself right down to the final answer just by using the method we just went through. So remember, we substituted the value for y in the straight line equation for y in the equation of the circle. So we're going to substitute kx into this equation. So that's our starting point. This gives us x squared take 10x plus kx all squared take 12kx plus 57. So you can see every time I've got to y, I've substituted in kx. Now we have to do a little bit of tricky rearranging. Write the x squared terms next to each other and the x terms next to each other. So I've written x squared plus k squared x squared next to each other here, and negative 10x take 12kx next to each other here, and we still have that plus 57 on the end. And I want you to think of this k as a constant. Think of it as a number. Even though we don't know what it is yet, try not to think of it as a variable like x. Now what you want to do is to factorize out the x squared from these 2 terms and the x from these 2 terms, and we'll get this. So k squared plus 1 if we factorize out x squared, and then 10 plus 12k. So I've factorized out effectively negative x from those 2 terms. So if we expand that out again, we get negative 10x take 12kx, and still the plus 57 on the end, and all this equals to 0. Now here is why I was talking about the discriminant, and also why they make this point, that the line intersects the circle at 2 points. That means this quadratic is going to have 2 solutions, And if you remember from your knowledge of the discriminant, that means the discriminant must be greater than 0, as this quadratic has 2 solutions. Again, if you're not sure about this point, check out that video in the description where I talk about the discriminant in detail. So now what we want to do is substitute in B and A and C into this inequality, and that's actually going to allow us to calculate our range of values for K. So B in this quadratic is the coefficient of X, so it's 10 plus 12K. A is K squared plus 1, and C is 57, just like normal. Okay, so let's substitute those in. So B is 10 plus 12K all squared. You could substitute in negative 10 plus 12K, but because we're squaring it, it's still going to be the same. Then A is K squared plus 1, so 4 times K squared plus 1 times 57, and this needs to be greater than 0 for this quadratic to have 2 solutions. Let's go ahead and expand out these brackets and simplify. So expanding out the first set of brackets, we get 100 plus 240K plus 144K squared. And then 4 times 57 is 228. So this is going to be negative 228 multiplied by K squared, subtract 228. So these two terms are from this set of brackets here. And all of this is greater than 0. Let's simplify. So 144K squared, take 228K squared. That is negative 84K squared. Then we just have 240K, and 100 take 228 is negative 128, and this is all greater than 0. Then we can divide by negative 4. Why am I dividing by negative 4? Just to get rid of this leading negative. I would prefer if this number was a positive. It just makes it easier for me to think about. But remember, when you divide by a negative, or divide an inequality by a negative, you need to flip the inequality sign. So dividing this inequality by negative 4, I get 21K squared subtract 60K plus 32 less than 0. All right, now we're at the stage where we have a quadratic inequality. And this is another skill you learn in GCSEs. I have a video on solving quadratic inequalities if you want to check that out. And the first step to solving a quadratic inequality is to find the critical values. We do that by solving this equation. 21K squared takes 60K plus 32 equals 0. Now we can try thinking about if we can factorize this. Eventually we realize we can't factorize this quadratic, so we have to use the quadratic formula. K equal to negative b plus or minus the square root of b squared take 4ac over 2a. Plug b, a and c in there. Hopefully you are pretty good at that by now. B is negative 60, a is 21, c is 32. Plug those in. I would suggest pulling out your calculator. Don't bother doing anything else. You could simplify these numbers if you want to, but why not just plug it all in as is? Plug that into a calculator. First plug in the positive square root, then the negative square root, and you'll get two values for k equal to 0.7095 and so on, or k equal to 2.1476 and so on. And as this quadratic is less than 0 and it's a positive quadratic, that means k is going to be between these two values. Also, the question says round to 2 decimal places, so we get a final answer of k greater than 0.71 and less than 2.15, and that's our final answer for that question. Okay, so that's about it for this video. We talked about the equation of the circle and finding where straight lines intersect with the circle. Here are some homework problems for you to have a go at, and I'll leave the answers in the description so you can check that you got them correct once you give them a go. First one says QR is the diameter of a circle with center C, Q equals 11, 12, and R equals negative 5, 0. Find the equation of the circle. Question 2 says find the coordinates of the points where the line x plus y plus 5 equals 0 meets the circle x squared plus 6x plus y squared plus 10y take 31 equals 0. And the last one is the line with equation y equals 2x plus 5 meets the circle with equation x squared plus kx plus y squared equal to 4 at exactly 1 point. Find the two possible values of k. This is an exam style question worth 7 marks and similar to the example we just went through. So good luck with those. I hope you found this video useful. Thanks for watching, and I'll see you in the next one. Bye for now.